So day 2 of Law of Cosines, you notice the formula has not changed. It is the same as it was yesterday, and hopefully you're getting better at that pattern. If side A is out front, angle A is at the end, so forth and so on. You know, basically it's Pythagorean theorem with that little fix that I talked about yesterday that kind of, but not really, turns it into a right triangle for you. That helps people kind of think of it that way. And so let's face it, nothing really new there, but what's new is this right here. What haven't I given you? I haven't given you a single angle. Okay, I gave you 3 sides, but so have I given you 3 bits of information? Yeah, do you have a pair? No. All right, so let's fill in this information. BC, where are we at? Is 8. AC is 15, and AB is 12. Now I'm going to give you a helpful hint of what I do. You remember that yesterday with law signs, and what I just kind of said earlier today is sometimes law signs has multiple answers, and all your calculator knows to do is to give you the first one, right? Well, I can give you a little helpful hint on this particular type that should avoid that problem. Whenever I have this particular setup, when I'm given all 3 sides, basically I can go figure out any angle I want first, can I? Does it really matter which one I go for first? Because if I find any of those angles, will I have a pair? Yeah. And so what I do to try and avoid the law of sines problem is I go for the biggest angle when I'm in this situation. Okay? So when you're in law of sines, go for the smallest one. Law of cosines, if you have a choice, go for the biggest one. And so if you're looking at these, yes, we have angle A, we have angle B, and angle C. Of those 3, which one obviously has to be the biggest in this problem? B has to be the biggest. And so we're going to use the formula that has angle B in it. And of the order that we had it yesterday, is that the first one, the second one, or the third one? Yeah, that's the second one, right? And what happens to be out front of that one is B squared, right? So here's A and C, right? I'm hoping the more I write this, the more you see it, the more it becomes in your head. Then it's minus 2 A, C. Remember, the only reason I'm capitalized the cosine there is because then you don't see the 2 C's right next to each other. And it'd be cosine of B. Now, the nice thing about this one is there is still only going to be one variable that we don't know. Do we know A, B, and C? Yes, we do. Do we know angle B? No, that's the problem. So let's fill in what we do know. Do we know side B? Yes, it's 15, but we are supposed to square that. Equals 8 squared plus 12 squared minus 2 times 8 times 12 times cosine of, well, unfortunately, we don't know. Are there any questions of how I substituted that into the formula or why I chose that formula? Now, did I have to? No. I didn't have to choose the biggest, but I think it's just a helpful hint. It kind of avoids the law of sines problem. But remember, that's in this setup. Now, here's what people have wanted to do in the past. They have basically wanted to type all of that in and figure out what that says. And they say that all of that is times cosine of B. Do you agree with them? Is all of that I just underlined in red times cosine of B? No, it's basically just this part that's times cosine of B, right? So don't try and do all of that and say it's times cosine of B unless you want to get them all wrong, all right? Because that's not algebraically what it's saying. But what we should probably do is let's go in and find out some of these numbers then. So here's what I mean, that you can't quite type it necessarily straight in this time. Once you get better at it, you'll find what you can type straight in and kind of work with it. But for right now, let's kind of go step by step so you don't get confused. So 15 squared, does anybody know what that one is? 225, okay. Equals 8 squared, okay. Plus, anybody know 12 squared? Okay, yeah, I think we had that one yesterday, didn't we? Now, can I actually take basically a negative 2 times a positive 8 times a 12? Is that something we can do? Yeah, we can put those together, and what is a negative 2 times a positive 8 times a, I don't even know where my stuff is. Negative 192, okay, so we got negative 192. Is that negative 192, is that times cosine of B? Yeah, that much of it is. That negative 192 is what we call the coefficient of that term there, of cosine of B. Okay. So are there any questions where any of those numbers came from? Okay, any questions where they came from? Now, here's now what some people do. They take the 64 plus the 144 minus the 192, and they say that's times cosine of B. And it's not. The only thing that's actually times cosine of b here is the negative 192. So let's just leave that there for now. Can we add the 64 and 144? Is that something that you can do algebraically without causing problems? Yeah. Okay, so we've got, what do we got here? 225 equals, well, what is 64 and 144? That's 208 minus 192 times the cosine of b. Because let's face it, what we're doing right now is we're trying to get a pair so that we don't have to do law of cosines again. So does anybody see something I can do algebraically next to this? Again, our goal is to do what? Get the variable by itself. Is it by itself right now? No, right now our variable has a negative 192 in front of it and a cosine in front of it. So, and a 208 kind of on the same side. So what should we get rid of first? We got to get rid of all of it. Get the 208, let's get that out of there. And how are we going to get the 208 out of there? Yeah, let's subtract. So did I subtract 208 from the right side of the equation? Have I subtracted it from the left side yet? Not yet, but I will. 17, thank you. Just so that you know, this can be negative over here. That's fine. That can happen. Where this 17 is, don't get freaked out if you have an assignment and all of a sudden that turns negative. What happens with the 208s? They cancel. Is that negative still there, though? The negative, yes, it is. Very good. Some people just kind of stop writing it, and then there's all sorts of trouble. Is the variable by itself? No, we still got a negative 192, and we still got a cosine. Let's face it, the most complicated part is the cosine, right? So let's save that for the end. So how's that negative 192? How is that actually attached to the variable? By multiplication, right? So how are we going to get it out of there? Divide. And take the negative with it. Let's face it, we want to get rid of the negative too, so might as well get that out of there. What I'm trying to do is get you to a point where you can just type it into your calculator and get the answer. So do you agree if I take 17 over negative 192, your calculator would give you probably a really bad decimal, right? A really bad negative decimal. Okay, but let's think about that. That's obviously not what b is, right? That can't be. But that's what cosine of b is. You have learned how to get cosine off of that angle by arc cosine. Very good. Because let's face it, this is gone. So we are going to take arc cosine, which we normally abbreviate like that. So you do it of both sides, and that will give you b. So I'm going to give you a second to write that down. I'll write it down on this other board over here so that I can type it into the calculator. Any questions on how I got to where I am? Yes, now when you go to your calculator, the very first thing you should do, and I did it earlier because we were doing some examples, but check your mode. We're good with degrees, all right? And so we've got arc cosine. If you don't put arc cosine on there and just do cosine, you're not going to come up with the answer you want. Now here's your 17 divided by, now again, we have two buttons that kind of give you that negative or minus. Do I want to do the gray one this time for minus, or do I do the white one on my board? Yeah, you got to do the white one this time for this, like the opposite of 192. Because otherwise your calculator is going to ask, what do you want to subtract it from? You want to subtract it from the division sign? How does that work? What do you, I don't get that. All right. And we get, is it possible to have a triangle with a 95.1 degree angle? Yeah, that's possible, isn't it? It's obtuse. Okay, and did I say we're to round on this one anywhere? No, so for our purposes today, let's round to the nearest tenth. We'll say 95.1. Now, I know that seemed like a lot of work, but was any one step really all that hard? No, were there a lot of the steps, though? Yeah. So the hardest part of this is remembering what order to do things in. So here's angle B is, what do we say, 95.1 degrees. And the reason I tell you to go for the biggest when you're doing this particular setup is, like I said, now law of sines, it can't possibly go wrong. But you might want to still stick with that pattern when you go to law of sines, get the smallest one. That way you're just safe and you're in that pattern. Okay? Because I did say to solve the triangle. But before we go on, because I think you're getting pretty good at law of sines, I'm not too worried about that one anymore. But how about law of cosines? Any problems with that? Again, where's the biggest spot for a mistake is people just put all these numbers together and say they're all times cosine of b, and they're not. Please try and remember, it's just that stuff that's times cosine of b. Okay. Any questions on that? All right, well, let's finish it up then. Is everybody okay then if I erase the law of cosines work? Okay. In fact, I'm going to give you a second here. Why don't you go ahead and try and get angle C for me using law of cosines.